In this video, we're going to look at another elimination reaction, this time a dehydration reaction, and we're going to do so by looking at the dehydration of propan-2-ol. So first, we're going to talk about what a dehydration reaction is. From its name, we can see that dehydration is going to be the removal of water. Now, this removal of water is going to be specifically in the form of a hydroxyl group and a hydrogen. And these two are going to be from adjacent carbon atoms, meaning next to each other. So we're going to look at the removal of water from ethanol, just so that we can see the basic mechanism, and then we'll look at another example of propan-2-ol. So I'm going to draw ethanol. So I'll draw our OH at the top of our second carbon, and then the rest will be hydrogens. So these two carbons are adjacent, they're next to each other, and we're going to get rid of this OH group as well as this hydrogen. And we're going to form a double bond when we do so. So we're going to just react this in the presence of a strong acid. This strong acid is a catalyst, meaning that it is not actually a reactant, it's regenerated during the reaction. So we put it over the arrow. When we react it with this catalyst, we're going to form a double bond. So we're going to remove that H and that OH. We'll form a double bond between the two carbons they were originally on. And we'll be left with ethene. And then our inorganic byproduct is going to be water. So that hydrogen and that hydroxyl group are going to bond to form water. So now we're going to look at the example of the dehydration of propan-2-ol. So we're going to start by drawing propan-2-ol. So on our second carbon, we'll have our OH. This is a secondary alcohol. And hydrogens everywhere else. So we're going to be looking at this hydroxyl group here and the carbon it's on. So we can remove a hydrogen from either of the adjacent carbons. So our adjacent carbons are highlighted here in yellow, and the hydrogens that are ready for removal are going to be highlighted in yellow as well. So we can remove any one of these highlighted yellow hydrogens. We'll get the same product in this case, regardless of which one we remove. So we're going to have our strong acid catalyst, and I'm going to remove, so this hydroxyl group is going to get removed, as well as this hydrogen on this first carbon here. And so when we remove those, we're left with a double bond between our two carbons, still a single bond between the third, and so we haven't taken any hydrogens off of that third carbon. We're still left with our hydrogen on that middle carbon, and two hydrogens on the end. And we have formed, propene, and then water as an inorganic byproduct.